Okay, so this is what I call my orange RC10. It has the RPM Worlds Conversion Kit for both the rear suspension and the front suspension. I've run this car for the last 2 years at the Vintage Off-Road Nationals, and it handles very well. But well, there are kind of two problems I've had with it. One is the jumping performance. You can't get a whole lot of droop out of this car before the dog bones pop out. So anytime I'd land a jump, the car would, the chassis would just slap the ground, and I could try to stiffen the rear suspension or use thicker oil or something like that, but that would also affect the handling, and I really like the handling. So, and as it is, the shock angle is already at the lowest possible angle. I'm all the way inside on the upper hole, and all the way outside on the lower hole here for the shock mount. Now, this particular shock tower is not a typical RC10 shock tower. So if I get the World's Car shock tower, for example, it would have another hole on the inside that I could probably use. This particular tower, I think, is from Revolution Design Racing Products or something like that. It only has 3 holes here. So maybe I can go a little lower on the shock angle with a proper RC10 tower. But I like the look of this fiberglass tower, so I kind of want to keep it. So the main reason for that is because when you do this conversion, you have a kit that helps you to narrow the rear of the chassis to account for this different type of rear inner hinge pin mount that comes from RPM. And it also accounts for the fact that the rear arms are wider than your standard RC10 arms. And while you're doing all of that, you're not changing the length of this dog bone. And what ends up happening is that the position of the end of this dog bone here going into the hub carrier is a little bit further out than what it would be if you just have your standard setup with standard RC10 arms and RC10 hub carriers, etc. And so you can't get quite as much droop out of the arms before the dog bones pop out of the diff out drive. And you really got to play games with shimming the wheel axle here against the inner bearing just to make sure you get as much droop as possible before anything pops out. And that this is the maximum droop I can get. It's really not a whole lot. And the other problem I had was at the last vintage race, this was 2016, I found that I didn't have quite a lot of traction, rear grip, and when I looked at the camber, I found that actually my camber angle was a little too high. It was at around maybe 2 degrees static camber at my static ride height. So I tried to back that off to 1 degree, should give me a little bit more forward bite, and just that 1 degree change did enough to pull the dog bone out. It's just that the dog bone, especially on this side, the other side was okay, but on this side, it was just enough to make it pop out under certain conditions on the track. So the next qualifying round that I ran, the car felt awesome. Then like a minute into it, dog bone popped out. So, how do I fix that? So I was thinking about, finding a way to maybe use a longer dog bone so that I don't get a dog bone that pops out, and I can have, the static camber that I want. And I tried playing around with using like a B4 hub carrier with a B4 CVD, all the different associated CVDs or CVAs that I have. The dog bone lengths were either too short or too long. So it's not like a typical RC10 World's Car where you can play games with using, say a B4 hub carrier with a B44 CVD, or like the Dynotech rear arms, which are longer, and then you have the RC10 GT hub carrier with a B4 CVD to account for the offset. Like, you can play all those games. On this, the arms are just a certain type of length that you can't really do that. So I started looking at other manufacturers for CVDs, and sure enough, Kyosho came to the rescue. And this one actually seems to work. This is their UM510 62.5 millimeter length dog bone. And this is just the right fit. So what I did is a test fit on this side. And in order to mount this particular unit into a rear hub carrier, because this uses metric bearings, I had to use a metric hub carrier. So what I'm using is the Kyosho LA244. This is the rear hub carrier that used to be used on the RB5. You could also probably get away with their RB6 equivalent part. The reason why I wanted to try the RB5 part is that it had a few more adjustment options. Here, let me see if I can just take this out of the bag here. Oop. So on the RB6 hub carrier, you only have one mounting hole here at the bottom, okay? And with that one mounting hole, the ball stud height ends up being a little bit too low compared to what you would get with the stock setup here with this RPM hub carrier. So I have to go to this middle hole here to push everything up a little bit so that this ball stud height here is roughly in line with what you get on the RPM hub carrier. Not perfect, but I could use maybe a 1 or 2 millimeter spacer there to get it just right. So not much adjustment needed there. And I would have to bore out this mounting hole here to account for the hinge pin. I think it's a 3/16 inch hinge pin, which is a bit wider diameter than a 3 millimeter opening here. So, okay, that's a small modification. But what's also good about this is the hub carrier is smaller than the arm opening. So I can put spacers in here to move, the relative weight of the motor either, further forward or backward with respect to the wheel axle. So it does give me a bit more adjustment. I also have 2 mounting holes here for the outer ball stud. So if I wanted lower camber gain, if I line these up perfectly, right, this ball stud position in terms of in and out aligns pretty well with this inner ball stud location. So if I needed lower camber gain, I can go to the outer ball stud, which tends to be preferred at the wall kit track where we have the vintage off-road nationals. You tend to want to run low camber gain. So this is actually like the perfect setup. And so I just test fit this, 2 5x10 bearings go on the inside. No spacers or washers or anything, no shims on between the wheel axle and the inner bearing here. And the, let me just move this a little bit so you can see. The dog bone slots pretty nicely into the diff out drives. There's very little play. There's no excess dog bone extruding out of the hub carrier, which is good because you can see on this side, where is it? Right here, there's a little nut there that I used to help hold down the screw that mounts this inner hinge pin brace. And that actually runs very close to the diff out drive. So if there's extra material from this pin coming out of the diff out drive, it'll hit this nut and everything will lock up. But it actually works just fine. Okay. And I can do, full compression of the suspension, and the dog bone doesn't run up into the actual diff, nut here. So I get full suspension travel, and the outdrive, or the dog bone, is further into the diff outdrive, as opposed to on this side. Maybe it's a little more difficult to see. Let me get a good angle here. Here I'm right at the outer edge. So it buys me a few millimeters here of dog bone travel or play, if you will. So if I wanted to, I can take the some limiters out of the inside of the shock body, or unscrew the eyelet here by a few turns to bring the droop down a bit more, and to give me some more suspension travel. So this is just a test fitting, but it looks like it works, and it does give me more adjustability in terms of weight distribution and roll center and camber gain. Right here you just have a single ball stud position, no other holes. So there's a fixed camber gain and a fixed roll center. I can have more roll center adjustability with this. I can have more camber gain adjustability with this, and weight distribution adjustability with this. So this looks like a really good setup here for this particular type of RC10 with this RPM rear end. So if you have this type of car, I'd suggest giving this a try. Even though the wheel axle itself is metric, the RC10 dished wheels here do slot on pretty nicely. I'd have to check to see if the drive pin fits well into this opening, these little slots here on the wheel, but they should. And if they don't, you could just go back to your standard size drive pin, whichever is smaller between that or the metric one, and it should be fine. There shouldn't be a whole lot of play in there. So this I want to try out when I get back to the track, just to see you know, how well it works. Do I get better jumping and landing behavior with this higher amount of droop compared to what I had before? The only sort of downside I can think of is if I increase the droop, then when the car is cornering under a full cornering load, the outside wheel may end up... no, it won't lift, will it? No, it shouldn't lift. Should be okay. But I may end up losing a little bit of traction on the inside wheel, possibly. So we'll see if it affects the cornering behavior too much. But anyway, that's a little trick that I just came up with that I want to share with you guys, and hopefully it will help improve the performance of this particular car. So that's it. Thanks for watching.